So this is my idea for 3D reconstruction from videos, and I had a little bit of fun with this. So I got videos from VR tours from YouTube, from handheld devices like a phone obviously, and then I used Gaussian Splatting to kind of create scenes. And right now I've moved quite quickly, so we're not going to see a very clean splat, but you're going to see why things work as we go along. So this is one of my videos I used, and this is the splat that I created from this. It's not the best, and I think you can see just from the way it looks where some of the limitations were from a shaky handheld phone. I mean, I think it's an S26, so the camera's not as good as a brand new iPhone. Still, we made some progress. And then at the end of the clip, I did some semantic analysis here and there. Person, door. I mean, it's not perfect. Computer, not even close. But wall, door, computer. It's not the best, but the potential is there. With a bit of tweaking, I'm sure I can improve the accuracy, and using a few other tools, maybe YOLO as well, because I'm familiar with that. It got stairs correct, so it got wall correct, it got door correct. I think it's not too bad. And then if we move on to, let's close this. If we move on to one of my favorite videos, this is the ITER. It's a nuclear fusion plant in France right now. They have a VR tour. What I did was I just took a video of that. I had to slightly pre-process it, so make it a little bit bigger to remove the points which aren't useful. That might have affected the image very, very slightly, but that's the cost I'm willing to live with in this. You can see right now, camera is going at a fixed interval or rotating at a fixed length, and much higher quality video. And then you're going to see the splat I got was, oh my god, it's just amazing. It looked neater, and you can see at this point here, that's because I cut the clip out here. There's a little yellow dot you press to go to another place. I figured, let me just remove it rather than pre-process it or try to mask it. But this is the splat I got, and I'm really happy with it. It's very, very, very good. But I'd argue this is probably a very high quality data set compared to the video in hand, and a bit harder to get. And if I can find the image viewer now, how does the semantic analysis do? Wall, shelf, stairs, no. Ceiling, no. Still, it's not great, but I suppose with some pre-processing, as I said, I can probably get this to be a lot better. Okay, so I'm gonna hopefully power through this now. I'd say the first key step to do is get some data. So the video recorded on the phone, like any phone can get that for you pretty easily. This is a VR tour. This is a VR tour. I would argue this is almost like perfect data in a way. We also have an AI video. We have some games as well. That's it. This is a phone as well. So yeah, get the data. Once we have the data now, the important thing is to work out, do I pre-process it, do I clean it, and how do I do that? So once again, this is the VR tour that ITER do. It's that thing right here, and it's literally a £40 billion project, so they're obviously going to give you very clean data. One thing to note now is this little thing here it's not a problem. In hindsight, I would have liked to mask it out, but basically I got myself a video, and then I kind of cleaned it to be in a nicer format for myself. And when I say clean it, I mean, okay, if we have this file right now, I'm going to remove the top bit here and the yellow bit, and that little icon here is going to go. And I'm going to remove, let me just try actually. So, what I don't like this, I don't like this, I don't like this. And I don't like this at the bottom. Okay, so my solution, because it's just testing an idea right now rather than coming to a real solution. Sorry, that makes some sense. It's just about testing 3D reconstruction. So I was okay leaving these artifacts as is. So basically, I'll cut this down here. I'll cut this down here. I'll basically ignore this. Oh, and down here as well. I'll kind of change my file from this form before to this after. I have slightly tweaked the dimensions a little bit, but I don't think in this case it will matter too much. Another example of pre-processing is, if I can go to a game call now, I used a game for my another file. Look how many filters and exposure we have. So exposure is how bright we make the game, how dark we make the game, and filter is what kind of colors we use. This could matter at different stages for robots and vision, but I think for the 3D reconstruction, I'm just going to hope that the base level, the base layer, whatever it is, it will work. So I'm not going to do anything too fancy on that end. And spoiler, sometimes it worked, sometimes it didn't. And then pre-processing, yep, you've already talked about this one already. Actually, good point now. This was my favorite video, and what I decided to do is I had the video start from here to here. It's a whole circle actually. I decided to remove this bit here, which has the it has that in it. So in a way, I just cut out this little yellow circle. Masking it would have been the correct decision because I know what color it is, and this color is distinctly different to every other color, so that would have been an easier solution to do. And then when you look out this splat, which is my favorite splat, I think, and this is maybe a lack of knowledge here, this little gap here is where I had cut out this. So had I not cut out that bit, I think we'd have a bit of a nicer splat, or a more complete version. I still think I achieved the objective without it, so it's not too bad. It's just a thing I could have done nicer next time, you know? And then I wanted to talk about pre-processing one more time now when it comes to images. In one of my master's units, I did brain scans, and I think if this is 1920 by, let's say, 1080, I don't need to scan every single pixel. What I could do is just crop this out because these have no data. Then I go from, let's say, 1920, let's just say 1000. Let's cut here actually. Even more. Even more. Even more now. Okay. Let's say we've gone from 1920 to 1080 to, I don't know, 1000 by 800. We've lost a lot of... No. We're being more efficient in what we run and what we test. One thing I thought could have been interesting, if I duplicate this page actually. Nice. This. You could just crop this, and then make it bigger. The issue is, if you're scaling up, you're kind of stretching pixels, and you might lose like really fine level of detail. So in this approach, I use Kdenlive. I stretched it a very small amount, but I think it's negligible. And that's where the pre-processing comes into play. Like, here's the data, here's how I got it, here's how I chose to pre-process it. I admit there are some weaknesses, there are trade-offs in doing this. I don't think it will affect the final product too much. And if it does, I can always revisit it later, which could be this case, like right here. So, will it matter? Maybe, but I think this is more like exploratory. Like, I'm going to try it out, see what works, see what doesn't work. If I have time, I'll then fine tune and kind of try to get like higher accuracy or more, eke out performance possibly. Tools, again, I'm using Claude a lot to be fair, rather than just write code myself, but I can do quite a bit myself. So Conda to set the environment up, Python 3, CUDA, I've got two 3090s, PyTorch for deep learning, FFmpg, this is amazing. We're using COLMAP. I haven't used it before this, but it should be fine. I've seen Gaussians before this, not used it that much, but yeah. Nearest neighbor is fine. I think SAM is done by Facebook, and CLIP is just basically how do we segment and how do we label it. I've used YOLO before for labeling, so it shouldn't be too bad. Alright, so will it matter? I don't actually know yet, because one thing I've realized is the videos that I've done with my hand, they've been a bit shaky, they've moved very quickly, they're not a nice stable flow, but this is probably more like real life data. So we failed right now, but I decided to press on. I did try and stabilize the handheld video with some tools, but it just, I suppose with some more time I could try other solutions. I just tried the first obvious solution. It was a bit difficult. I moved from, I think, COLMAP's exhaustive matching to sequential. I'm not sure how that... So if I understand this correctly, exhaustive I think kind of goes every frame compared against every other frame. That's something I think I did in my master's deep learning project or something. But sequential is more like frame 1 to frame 2. Frame 1 to frame 2. Because I think in terms of the road outside, the street is very uniform. Like if we're moving slowly on a brick wall or a street, it can't really differentiate between concrete. So maybe there was no feature there. And the park, I guess, could have been too much leaves and foliage possibly. But I can maybe look at that later. Okay, so of the like 8 or so projects I've been using or testing, I think we got like 6 working. 1, 2, 3, 4, 5, yeah, 6 working. So we take the video that's now been cut, bang, bang. Here's our data set. We then extract the frames. We stick them here, so we stick them anywhere basically. Once we have the frames, we just start running COLMAP. We start running COLMAP features, and you can see, I think this was the ITER video. This is it's quite dense, I suppose, compared to the other, so it takes some time. And then there was some, there were some issues here and there, but ultimately it did function pretty well. And again, I could probably eke out more performance given more time, but just for the sake of expediency, we moved on. So I got some outputs from this now. I got a sparse, which kind of does the reconstruction. I got a database which kind of matches features and look at the frames, which is pretty nice. Speed it up now. Okay, so we then train it. We then test how it did against the original file to give us a score. We then view it. So viewing it is here. Pretty cool. Data score is here. I'm surprised how well the phone on the video on the phone did in terms of score, but it's more about reconstructing what you have. So this video was more like a walk in the building, turn around slowly, turn around quickly, walk back with diagram. And the ITER video was more like a very smooth, very uniform, very high detailed, very same angle exactly turn, which is smoother. And again, it just looks so nice. Okay, so we now have our splats or video frames. We run SAM2, I think, to draw boundaries on the regions. This reminds me of YOLO, you only look once. And then CLIP puts some labels on it. I think zero shot with like no prior context to this. So we got some no good, no good, no good, no good. I can see the argument for being shelf, and ceiling is correct. So for the first time doing it with no prior knowledge basically, I think it's done really, really well. And most importantly, what I would have liked to have done. I think now the most important thing actually is second, should be first, is phone is where we're going to get most of the detail, or you're not going to get ITER level VR data all the time. So finding ways to deal with this limitation is probably the most important thing I would like to have done. And along that vein, I could have probably looked at other reconstruction techniques to see how they work. And maybe one works very good for video games, maybe one works very good for phones. We don't, I don't know yet. So that's what I'd like to kind of probably do more on in this project itself, if I was doing it. And then better labels, that feels more like a nice to have, neat kind of thing to do. I'd say these two were the more important things I would have done with more time, obviously. So, will it matter? I think with more research on my end and like a few other tool sets, I could probably have found a way to make this valid. Or I feel like the way the industry's gone and the tools out there, it should be reasonably easy to get this to have worked. Because we know the phone recorded works, so yeah. That's my submission for the AI control. Any questions, just ask.